everybody, this is Mrs. Peachy from your WCA Physical Science class, and I'm doing a video tutorial for you today on your first portfolio for the semester, which is the virtual lab on Introduction to Scientific Inquiry. So just in case you don't know where to find these videos in the future, I know I sent you this link through webmail. Just remember that I actually do have a website, ladies and gents. So you can find that website by going to the message boards, or you can just look at an email that I sent you, because all of my emails have the website link in the signature. And when you get to the website, at the top of the screen, you are just going to click on, I'll go to the home page, but you're just going to go ahead and click on the little toolbar at the top that says Physical Science A, which brings you to our physical science class. And you'll notice that for every one of our physical science labs, there is a video tutorial that goes with it. So hopefully that's going to help you guys out a lot doing all of your labs this year. The other thing I want you to notice is that for each one of your physical science labs, there's also a Microsoft Word version of the lab sheet. Now in the past, the lesson will give you a link to a PDF for that lab. Those PDFs, they have problems with them, and oftentimes they don't save. And so what we found is that sometimes students will work really hard on that lab, it doesn't save, and then they submit a blank lab to me and have to start all over again. So rather than having to go through all of that, I've just gone ahead and made that Microsoft Word version, which you can download onto your computer, which we have right here, and we'll work on that today in this lab tutorial. Okay? So first of all, the first part of your lab, I want you just to open up this Microsoft Word version, and then we are going to kind of go through parts of this, because the first part of this is actually a hypothetical. In fact, numbers 1, 2, and 3 are all kind of hypothetical parts to your lab. And then we'll collect data in number 4 and 5, but that data is just kind of a simulated data. Okay, so this is combining two different things we're looking at. We're looking at the scientific method, the process of science, and we're also looking at some of the gas laws in this lab. So it starts off by posing a question. Have you ever had the experience where you've left a ball out in the cold weather overnight? Maybe as an extension to this, you've had an experience where you've gone outside with a balloon in the wintertime and see what happens to that balloon. So it says in this activity, you are going to be investigating how changing in temperature affects the gas inside of the container. So for question number 1, or for the introduction, it says, write a question about how changing temperature affects gas. This is a question. This isn't you trying to determine how changing temperature affects gas. You're just writing a question. You might say something, for example, like, if it gets really cold outside, what's going to happen to my balloon? If I heat up my soccer ball, will it get bigger or smaller? Those are questions. So we're not actually doing anything right now. We're just posing a question. The hypothesis is a statement, not a question. It is an if, then, because statement. Okay? So for your hypothesis, you are going to write now a prediction based on your experiences, or maybe based on the gas laws that you've been learning a little bit about here. Okay, focus that a little bit here. So maybe based on your experiences, you can make a prediction about what you think would happen. Okay, so if I change the temperature, and you have to say increase or decrease here, then this will happen because of this reason. So I want you in here to make an if, then, because statement. So I'm just going to go ahead and write down here. Oops. There. Actually, it's going to end up going on to the next page, I think. But I will go ahead and write. I'm going to change my color here just so that we can see what I'm doing. Oh, it didn't allow me to do that, so here we go. If I and I'm going to say increase, but you guys could say decrease, increase the temperature of a gas, then the volume of that gas will, well, you have to decide if you think it's going to increase or decrease. And I'm going to put in parentheses, because I'm not going to make that prediction for you. I want you to make that prediction. I think this because, and you can tell me why you think this. This because can be based on an experience you've had, because this is what happened to my ball when I left it outside. Or you can use one of the gas laws to justify your answer. And actually, in science, I want you to get in the habit eventually of, yes, using one of the laws that we've been learning about as justification, not just personal experience. Okay, but this is our introductory, so at this point you can draw on personal experience, but the best because would be because of a specific gas law, and not just saying because of Charles's law, but actually telling me what that means. Okay, but if you're not comfortable yet with, talking about one of the gas laws, justify your prediction with some personal experience that you've had. Once you've done that, then you're going to design an experiment. Now, you can be pretty creative with this. You're basically going to design an experiment to show how changing temperature affects the volume of gas. Okay, so your design here, again, I'm going to change this just so I can see it better to a different color, which didn't work. Sometimes it's a pain. Okay, so your experiment will be to show how changing temperature affects, the volume of a gas. Now, what could you do? I don't know. Maybe you could put a balloon on the top of a flask or something. Put a little bit of water in the bottom of the flask, put a balloon on the top and boil it on top of a hot plate. And you could see how, as I increase the temperature of the water in the flask, which is thereby increasing the temperature of the air, it changes the volume of the balloon. That's my scientific teacher thinking involved there. You could have totally different ideas, right? Maybe you could have an experiment with measuring the volume of a tire on your parents' car during the summer, during the fall, during the spring, during the winter, and determining how the changing temperature affected the volume of the tire. Right? There's just so many different things you could do. But remember that you need to just kind of describe something you could do to verify your hypothesis or negate your hypothesis. Then we come up with these two terms, manipulated variable. And responding variable. Okay. The manipulated variable is also known as the independent variable, and the responding variable is known as the dependent variable. The manipulated variable is the thing that you, as the person who's running the experiment, is going to change. When I do an experiment where I am heating up a flask of water and seeing how the balloon changes, I am changing the temperature of the air, right? That's what I'm manipulating. What's responding is how big that balloon gets. So the balloon's volume, I don't have any control over that, but it is in direct response to me changing the temperature. Okay? So that's the difference between manipulated, aka independent, and responding, aka dependent. All right, so the next part is you got to have some data. And this is where we're actually going to get to using the gizmo here. So I'm going to go back to this lesson. And I want you to go to, I think it's slide 3. And you're going to click on where it says Boyle's Law and Charles's Law right here. Okay? When you do that, it's going to open up this gizmo. And what you have the ability to do here is to alter the temperature and see how the pressure is going to respond. That's what you're going to do. It's a pretty straightforward and simple gizmo. It's not really my favorite, but it is what we have for this portfolio. I want you to notice that temperature is measured in Kelvin here. Kelvin is the scientific or the SI system of temperature. We don't use it all that often. We tend to use Celsius degrees more so, but Kelvin is kind of what they want you to use here. When you get to Kelvin, 0 degrees Celsius is the same as 273 degrees Kelvin. Actually, Kelvin, you don't say degrees, it's 273 Kelvin. Okay? So this is actually cold. It's basically the freezing point of water. Then you can increase the temperature to higher temperatures, and you can decrease the temperatures. Pressure isn't changing. Pressure is not changing because my container's volume can change, right? So if my volume were constant, if I didn't allow volume to change, then it would get to be greater and greater pressure inside. But in this case, what I'm changing, manipulating, in other words, is temperature. What is responding is volume. So temperature is changing, volume is responding. Okay? So I want you to notice a couple of details here. When you get to this tab, it says table. So I can actually create a little data table here, which is pretty cool. So I can see, let's say my experiment was if I put my basketball, I don't like using a basketball. That seems like a whole accident waiting to happen. Let me just say instead is if I put my balloon out in the sun, then it's going to get bigger. And I know this because in my experience, when I heat stuff up, it expands. I don't know. That's not a very good hypothesis, but. So then I can start off with, let me just reset this. I'll start off with 275 degrees Kelvin. Pressure is at 98.1 newtons per square meter. So I'm going to hit record. All right. Let me increase the temperature. I'll go up to 200 and let's go to 300. So the slider is kind of a pain sometimes. You can actually, I think you can type in this box. Yes, you can. So at 300, then my volume goes up to 2.54. I'll just do every 25. So 325, the volume goes up to 2.75, 350, 375, 400. Okay, so I got a data table here. So once you have your data recorded, the coolest thing you can do, the best thing you can do is hit export. So when I hit export, that actually takes and puts that data into an Excel worksheet for me. So I can see that here. So I can open up my Excel file. I'm just going to bring that over for you guys to see. Okay. And I'm actually going to, let me just move my thing. Once I do this, there's a few things I don't want. For one, I'm trying to see how temperature affects volume. I don't need this column marked pressure, so I'm going to go ahead and just delete that column. And I don't need this column marked moles, so I'm going to go ahead and delete that column. So then I just have those two columns. So I'm going to go ahead and just highlight those two columns, and I'm going to right click. And when I right click, one of the options I get is quick analysis. So if I click on quick analysis, I get the option of a chart. I'm going to click on chart, and I'm going to select line, and it's going to give me this beautiful line graph. You see that? Now the line graph isn't like the bestest yet, but it's decent. So what I'm going to do is I'm going to actually take this information. I'm going to first of all, I'm going to take this line graph, and I'm going to select, I'm going to double click on it, At the top here, do you see the different types of chart styles that I have to pick from? I want one that, let me see here. I guess I don't have that option here. Well, you can go ahead. Let's try this one. Oh yeah. So I'm actually going to go to where it says quick layout. And I want one that has the data table included right here. I want the whole data table included. So I'm going to pick that one. I like that one because then I don't have to put a separate data table on. Then, ladies and gentlemen, I'm going to click on this whole thing and I'm going to right click on it. And I'm going to do this one more time. I'm going to right click on this. Oops. Select copy. Go back over my Word document. Come down here and select paste. And I'm going to paste that graph right into my Word document. Cool, right? So now you got your data. You didn't have to do a separate graph on something else. It kind of did it all for you. I would just change some of these things. The title, volume, M3, I don't know what that means, so I'm going to change it to how temperature affects volume. And then I'm going to change this axis title here to let's see, what is that one? I guess that's the volume, right? In square centimeters. And I don't think it has an axis for the bottom. That would be temperature in degrees Celsius, or degrees, or in Kelvin, right? So, I don't know, it looks pretty good there, I think. So that gives you the whole data table that you need. And so, here, when it says making a graph, you don't need to worry about this one. I'm just going to have you guys write in this section, you know, see above, because you already put it in here. You don't need to do another graph. It's really a big pain to do the graph in the PDF, and this whole grid thing here is kind of a pain. You guys should know how to do an electronic graph, okay? So here is communicating data. It says, your written observations about what happened in the experiment is qualitative data. Write a short summary of what you observed. Well, you didn't observe much, but you can talk about the motion of these molecules. As you're increasing the temperature, what's happening to how they move. Okay, so you're observing that. That's qualitative data. The temperatures are the quantitative data. How those molecules are moving is qualitative. So I want you to describe how they're moving there. And then again, number 2 here, you've already done that. Which measurement is plotted on the x-axis? I think we said that was temperature in Kelvin, right? Which one's plotted on the y-axis? That was volume. At 350K, what's the approximate volume? Well, if you go use your graph, you actually have the exact volume here, but you can just follow that one up here if you haven't done that one. You follow the 350 up to the line and you follow it over to the y-axis. And that will give you the approximate volume at 350 Kelvin. And then, let's see, what would be the approximate volume when the temperature is 900 degrees? You're going to have to, this is something we call extrapolating. So if you were to continue that line, that trend, way out to 900, you could actually come up with a prediction of what the temperature would be at 900 degrees. The best way to do this one, ladies and gentlemen, is just to go back to the sim and put 900 Kelvin in here. And then you're probably going to get, oh, I guess it won't go that high. So you're not going to be able to, you're going to have to just make a guess. You're going to have to say, okay, well, if I were able to make my graph bigger, if I were able to make this line much longer, it's going to keep increasing at the same rate. Make a prediction of what you think it would be about at 900 Kelvin. And then finally it says drawing conclusions. After analyzing or interpreting your data, the next step in the inquiry process is to draw conclusions. Your conclusion should state whether or not the data supports your hypothesis. So in other words, that prediction you made at the beginning, does your data seem to back it up or not? Why or why not? Do you think that you were correct in your hypothesis or incorrect? If so, why? And then you're just going to write a brief summary of the experiment, including the hypothesis, the data, and the conclusions here for number 4. So, that in a nutshell, ladies and gents, is how you do your first portfolio, virtual lab introduction to scientific inquiry. If you have any questions or concerns, please give me a call at extension 2204, or you can send me a webmail message. Have a great day, everyone.